Hi, I'm Cullen, and welcome back to Module 4 of Networking Fundamentals. Let's go ahead and check out our agenda and get started here. Just a couple of quick things to go over in this module. We're going to focus on Objective 2.3, understanding media types. We're going to talk about twisted pair cables and also fiber optic cables. So the cables that connect devices all around the globe and that help make up the internet. All right, so wired networks. They're really important. And as wireless connections, like as easily accessible and as widely used as they are, we still depend on wired networks to send our data. Because even if we're using our phone, that phone's connecting to a wireless access point, and that wireless access point is probably connected by a wire to a switch. The most common type of wire used throughout networking is made of copper. It's called a twisted pair cable. And the cable that we rely to send our data super long distances at ultra fast speed is made of glass fiber. And that fiber transmits data via light. And we'll touch on that a little bit more here in just a few moments. But first, let's focus on twisted pair cables. So twisted pair cables, once again, they're very commonly found, the most common in fact. And the reason being is that they're cheap. They're pretty fast, and they're really efficient at sending data via electrical pulses. We got multiple types of twisted pair cables are available, and they can be installed temporarily or permanently. So if you take a look here down on the bottom right of the screen, we have a patch panel there, right? You have a port being terminated up here in the top right screen. Those are two permanent installations of twisted pair cables. And here you have something called a patch cable, which we typically refer to as an Ethernet cable. All right, part 2 of our twisted pair journey. Each twisted pair cable has 8 wires, and those wires are grouped into 4 pairs. Notice here we have a brown pair, we have a green pair, a blue pair, and then an orange pair. Notice that within each pair you have one that's solid, and then you also have one that is, I guess you would call it striped, right? It's white with an orange stripe in this case for this specific example, but that's the case for every single pair. Each pair is twisted, that's where the twisted and twisted pair comes from, in order to reduce something called crosstalk and interference. We'll detail what crosstalk and interference are in a little bit, okay? So don't worry about that right now. But then we surround all those twisted pair cables with a plastic jacket. That's typically what gives it that quintessential blue look that you see on a standard Ethernet cable, okay? All right, so patch cables. These are the cables that we use to connect one device to another, or one device to an RJ45 port. Each end of a patch cable is terminated with an RJ45 plug using a cabling standard. Okay, we're going to detail these cabling standards in just a moment as well. There are 2 different types of patch cables that we're going to briefly talk about, and they're called straight through cable and also a crossover cable. All right, so these cabling standards that we're about to touch on, they're developed by TIA-EIA, right? The Telecommunications Industry Association and the Electronics Industries Alliance. When making a patch cable, the twisted pair cables are placed in order, and that's part of the standard, right? The order is defined. We then use this device right here to do something called crimping. That's a crimper, by the way, in order to secure our wires into an RJ45 connector. Okay. Note here that that's placed down, trying to secure the cables into the connector. All right, so let's detail some of these cabling standards. You've got an older version, BOGB. Then we have the 2 that are most commonly used. We have 568A and then 568B. Notice here we've got got 2 models up on the screen for you. 568A follows a very specific pattern where you have the white and green, then white and orange, then solid blue, then white and blue, and then solid orange, and then the white and brown, and then brown. And then B is a little bit different here, okay? What you're gonna see is that the blue cables are in the same position, and then the brown cables are in the same position, right? So the blue occupy pin, sorry, I actually should probably just go ahead and show you over here on the chart here. The blue occupy 4 and 5, and the brown always occupy 7 and 8. The only thing that's different here is that the orange and green are swapped between a 568A and a 568B. All right, so we use straight through cables to connect PCs or the devices that we use every day to central connecting devices. The straight through cable, it's the most common type of patch cable, and it's called straight through because we use the same standard, right? The wires on each end are organized using 568B, both ends are, or they would both be organized using 568A. In contrast, a crossover cable is called a crossover because of the fact that if you start one end with the 568A standard, it crosses over on the other end to the 568B standard. So let's say that this PC1 here, and we have PC2. Let's say that this Ethernet cable is terminated with the 568A standard, and then PC2 is connected and is terminated with the B standard. Okay, we would use crossover cables to connect two like devices, like a computer to a computer. All right, so let's go ahead and move on back to the slideshow. Limitations of twisted pair cabling. As we mentioned before, there may be some interference with twisted pair cables, and so they actually can only run about 100 meters, which is just a little over 300 feet, before they start suffering from something called attenuation. And attenuation is just simply the difference between the amount of information that's being transmitted and the amount of information that actually reaches its destination. Okay. And so what attenuation is basically you're saying signal loss, right? So we're losing data due to attenuation. Twisted pair cabling, also susceptible to interference, like I just mentioned. And note that there are 4 different categories of twisted pair cables too. Probably should have isolated these on their own slide, but my apologies. You can definitely download these slides and do that on your own. Note though that Category 3 came before 5, 5 before 5E, and then 5E before 6, right? So notice how the maximum speed rates, the data transfer rates or bit rates, are increasing with each new category. Okay. All right, so we just talked about interference a little bit ago, and what is interference? All that it is just anything that can disrupt or modify a signal, and that ultimately would result in the corruption of data. There are a couple different types of interference. You have electromagnetic interference, you have radio frequency interference, and then crosstalk. Whoops. Electromagnetic interference can be given off by a microwave or anything that transmits an electromagnetic field. And what that can do is it can essentially just throw off those electrical signals that are being transmitted along a wire. Similarly, with radio frequency interference, radio frequencies can interfere with wireless communications, and so it may not impact the use of twisted pair cabling as much as EMI would, but it's definitely something that you should be aware of. And finally, you have crosstalk, and crosstalk actually occurs within an Ethernet cable. And so if you're sending data on one twisted pair and receiving data on another twisted pair, there may be some crosstalk that occurs where the electrical signals on one copper cable start to get mixed with the electrical signals on another one. And so that's crosstalk, and it can definitely lead to data corruption and attenuation. So, all right, let's keep on moving. To combat crosstalk, we actually can shield the twisted pair cables. And so not just crosstalk, but also just general interference can be addressed through the use of shielded twisted pair or STP cables. All that we do is we wrap each pair with an aluminum shield, and then we put all of our pairs back inside of a plastic jacket. Keep in mind, shielded twisted pair, typically a little bit more expensive than unshielded twisted pair. We also have a certain type of cable that's called plenum rated, and these types of cables are installed inside of walls or above drop ceilings like you might find in a school, where they can't be hurt by sprinkler systems or any other cabling that, or I guess any other systems that you might have, like lighting systems, things of that nature, electrical systems. And so plenum rated cabling is important because if there's a fire, these cables have a Teflon coating that makes them, that protects them, right? They don't give off high amounts of smoke, okay? They're used in these situations because standard twisted pair cables have a PVC jacket, which can actually emit a really deadly gas, which makes it really, really dangerous in a fire situation. So you definitely would want to use plenum rated for anything that happens to be near electrical work, happens to be hidden away in the ceilings, or embedded within a building's infrastructure, because you certainly wouldn't want to cause any more hazards than might have already occurred if there was a fire. So keep that in mind. All right, fiber optic cables, right? The last part of our cabling journey here. Fiber optic cables transmit data using light instead of electricity. We commonly just call them fiber. They're actually made of glass or plastic, right? That's what makes the fibers, is glass or plastic. They have incredibly higher data transfer rates, and they're used when in a situation when high data transfer rates are required, and also when data needs to be transferred longer distances. And that's because data can travel at the speed of light, which is really fast. You've probably heard that, the speed of light. Also longer distances, light can travel a much longer distance than electricity can before the signal degrades. And so that's why it works so well. It also happens to be a little bit or a lot more expensive in some instances. All right, so there are a couple different modes with fiber optic cabling, and this can be a little confusing, so do make sure that you're paying close attention right now. There's single mode, and it actually just carries data through a single ray of light, and light in this instance is created by a laser. It's used for much, much longer distances, like 10 kilometers up to 80 kilometers, which is really, really far. This is the type of fiber optic cabling that's used to send data across oceans, right? Just mind-boggling. Multi-mode is a larger fiber, so there's a larger fiber density, and that actually carries multiple rays of light. And the way that this happens is that LEDs are used in order to beam light at different angles in order to transfer the speed. So I can't really do it with my two fingers here, so I apologize. But what happens is the light bounces off of one side of the fiber up to the next, and it never actually hits the different light beams. They just go ahead and they intersect, and they're typically different colors of light as well. And this allows you to send multiple data streams on the same fiber. Super interesting as far as I'm concerned. But another quick thing, if you want to point back to the screen here, is that we use multi-mode fiber for shorter runs. Right, so it's just 600 meters, which is still a lot longer than any of your typical twisted pair cables, but it's something to be well aware of. Note that there are multiple fiber optic connector types. This isn't necessarily something that you're going to be tested on, but I honestly would strongly recommend that you go ahead and do a quick Bing search and take a look at the images for each of these connector types. Very fascinating stuff, how you build fiber optic cables. Finally, we do have a ton of different fiber optic cabling standards that are available. Definitely want to go ahead and take some time to review this chart. You don't need to memorize it, but do look for trends, okay? Definitely take time to look for trends. Make sure that you know and understand simple things like the specific cabling standard you want to use for the longest transfer distance, and also be aware of I guess what you would say the fastest transfer rate too. Look for things like that, and also look for the slower ones too. All right, so thanks so much for joining me, ladies and gentlemen. We'll do a quick recap here of Objective 2.3. We talked about twisted pair cablings. unshielded twisted pair and shielded twisted pair. We also touched on plenum rated cables as well. And then we just briefly glossed over fiber optic cabling and a couple of different fascinating aspects about it and how it's able to send data really far speeds at really fast rates. Thanks so much for joining me. I look forward to seeing you in the next module. Bye.